I am Professor Jo Rycroft-Malone. I'm the Executive Dean of the Faculty of Health and Medicine at Lancaster University, and as was said, it's my absolute pleasure to host this lecture this evening. This evening we're delighted that we've got three distinguished speakers with us. I'm just going to give you a very brief synopsis of each of the speakers. So we have Professor Emma Cave. Emma is a Professor of Healthcare Law and Director of Durham Centre for Ethics and Law at University of Durham, where she works very much at the intersection of law, bioethics and health from a research and a policy perspective, published very widely and focusing on understanding and shaping patient choice and emerging biotechnologies. We also have with us Professor Emily Jackson, Professor of Law at the London School of Economics and Political Science. And Emily's area of research, field of research, is medical law, and she's very distinguished in the sense of being involved in the British Medical Association Medical Ethics Committee, Deputy Chair of the Human Fertilisation and Embryology Authority, and Judicial Appointments Commissioner. Also, Emily is a Fellow of the British Academy and has been awarded the Nobel for her services to higher education. And then we have our very own Lancaster University Professor Stephen Wilkinson. So Steve is a distinguished professor at Lancaster University, a Professor of Bioethics, currently leading a large Wellcome-funded grant called the Future of Human Reproduction. A graduate of Lancaster University returning in 2013, and much of his research has been focused on reproductive ethics and regulation of reproductive technologies, especially the ethics of selective reproduction. Steve was also recently appointed a council member to the Nuffield Council of Bioethics in 2024. So we have, as you hear, a very distinguished set of speakers who are going to be exploring with us stem cells and their potential to reshape human reproduction and the very profound ethical, legal and funding implications of those questions. We'll begin with some short presentations from our speakers. Then we'll have a panel session with the speakers. Then there'll be an opportunity for you to ask questions of our speakers, and I'll come back and I'll facilitate that part of the evening. And then we hope that you'll join us afterwards for a drink at the end of the speaking session. So delighted to have our speakers here, and so without any more delay, I am first of all going to invite Professor Emma Cave to return to the podium. Thank you. Welcome now.
That's marvellous. Good evening, everybody, and welcome, and thanks so much for coming, and thank you, Professor Rycroft-Malone, for the invitation to speak today. It's a pleasure to contribute to this discussion. My background is in law, so my key interest is how we regulate this field going forward. One of the most extraordinary facts of human life is that it begins with a single cell. The sperm fertilises an egg. That cell divides again and again before it implants in the uterus wall and begins to organise itself into the foundations of the body. So this is a period of breathtaking complexity. And this evening, we'll explore how stem cell research is helping us understand those earliest stages of human development, and in future might help to transform them. Stem cells have two remarkable properties. First of all, they can renew themselves, producing more cells like themselves. And second, they can develop into other specialised cell types. How about this interference? I think it's my hair. Excuse me. Human embryonic stem cells were first derived and grown in the lab in the late 1990s. About a decade later, scientists learned how to reprogram ordinary cells, so skin cells or blood cells, back into a pluripotent state, meaning they can once again give rise to many different kinds of cells. As Professor Wilkinson's project is showing, this field has transformational potential. That includes the possibility of new fertility options, but I want to begin with other equally important benefits: the creation of new models of early human development and what those models mean for our understanding of early human life and how that could lead to improvements in the applications in medicine. As we'll see, stem cell research promises exciting advances, whilst also raising serious ethical, legal and social questions that require public discussion. For so many, the journey to start a family is filled with hope. But it can also be a path of profound difficulty. Around 10 to 20% of pregnancies end in early miscarriage. 1 in 39 children are born with a congenital condition. We know that globally, fertility is declining, and that in the UK, 1 in every 32 births are the result of IVF. On average, the success rate of IVF is 31%. Now, these are important statistics, but they're not just statistics. They represent deeply human stories. And incredible though the advances in fertility treatment are, they point to gaps in our knowledge about the very earliest stages of our own creation. So, how can we study these early moments ethically and effectively to help us understand and advance human reproduction? Well, it's very hard to observe in vivo, which means within the human body, for obvious reasons. Now, that gets a bit easier later in pregnancy, but it's very difficult in those very early stages. In vitro, so in the lab, embryo research is sanctioned by law, but subject to special licensing requirements up to 14 days from fertilisation or the appearance of the primitive streak. However, a problem is this: between around 14 and 21 days, when embryo research would be unlawful, a process called gastrulation happens, and that's when the fundamental body plan is laid out and the foundations for our organs are set. This is a crucial time in the formation of the body. The biologist, Lewis Wolper, famously said, "It's not birth, marriage or death, but gastrulation, which is truly the most important time in your life." But that period is also a black box that we know very little about. The innovations in stem cell research open up a new route to study this period, and it's called, this particular type of innovation, which I'm going to talk about, is called stem cell-based embryo models. Scientists take human pluripotent stem cells, which have the ability to become many different cell types. They put them in culture, they provide the right nutrients and the chemical signals, and they guide them to self-organise into structures that resemble aspects of the human embryo. Some of these models mimic very early embryos comprised of just a few cells, whilst others seek to model aspects of the later, more complex embryo. Those tend to focus on certain tissue types or cells rather than trying to mimic the embryo in its entirety. It's crucial to understand what these embryo models are and also what they're not. They're not created by fertilising an egg with a sperm in the way that natural embryos are created. Instead, these stem cells come from embryos or from other cells in the human body, such as blood or skin cells, which are programmed to go back to their embryonic state. Public dialogue exercises have shown that many people consider there to be core distinctions between embryos and embryo models. Studies show that people tend to focus on 2 key questions: the origin, so are they created from a sperm and an egg? And also their potential, can they become a person? And for embryo models, the answer to both of those questions is no. They're created for research and not for reproduction. The potential benefits of this research are considerable. First, for reproductive medicine, that we could improve our understanding of why so many IVF embryos fail to implant, potentially leading to higher success rates. Second, for safer pregnancies. Because these models could be produced in large numbers or used alongside other models, such as models of the uterine lining, we could use them to test the effects of medicines to ensure they're safe for use during pregnancy, and that's something that's really quite difficult to do now. Third, we could gain invaluable insight into how conditions like preeclampsia, fetal growth restriction, some congenital heart defects, for example, would arise. That's because their origins often lie in this very early, hidden period of development. And also these models offer a powerful way to reduce our reliance on both embryo research and animal research. Overall then, the promise of these embryo models is most immediately for science, but further down the line is potential for these models to bring benefits to families through clinical applications. Now this science rightly brings up important ethical questions, and it's a conversation that we must have openly. Public dialogue has shown that people have valid concerns about the embryo models. How similar are they to human embryos? Could they ever develop features that the public has identified as clear red lines? Things like a nervous system, a brain, or the capacity for consciousness, or being able to feel pain. The concerns also extend to them resembling a fetus, even if they aren't physiologically very like a fetus. And even though it's not the current intention, could they ever in future be used for reproductive purposes, avoiding the need for fertilisation, which would change human reproduction? Plus, in a recent public dialogue, many people were surprised to learn that there's a governance gap, that our current laws, written over 30 years ago, don't specifically cover this new technology. In response to this gap, and the public's concern, the conversation about governance is already moving forward. One potential solution is to treat these models in the same way that we treat embryos, because we already have laws and regulations that govern embryo research, imposing limits on culture time, the 14-day limit that I mentioned earlier, and special licensing requirements. But treating all embryo models as embryos would have two very major drawbacks. First, it would treat as embryos entities that don't have the same moral significance, because they only model aspects of embryonic development. This wouldn't be a neutral act because there's an ethical cost to preventing gains in scientific knowledge and the potential clinical applications that I mentioned earlier. Plus, those regulations that govern embryos were designed over 30 years ago for human embryos that are created by a different process, the process of fertilisation. Embryo models don't start with fertilisation. They don't develop at the same pace or in the same linear fashion, which means that the law and regulations wouldn't fit. To address the gap, the research community, with input from the public, has begun to establish a voluntary UK code of practice for this research, and that's a crucial first step. Looking further ahead, the Nuffield Council on Bioethics, which is the closest that the UK has to a national ethics committee, set up a working group in 2024, which I chaired. The final report made recommendations about future regulation. We recommended that the law should be changed to ensure that the HFEA, the Fertilisation and Embryology Authority, which is the fertility regulator, alongside other regulators, could work together to approve and to monitor and to oversee embryo model projects. The Nuffield Council also argues for changes in the law to set out clear red lines on what should not be done. In particular, preventing human embryo models ever being placed in the reproductive tract of an animal or a human for reproductive purposes. So to bring this to a close, I want to leave you with 4 key messages. First, these models are a valuable new tool that complements but doesn't replace research on human embryos. In fact, to validate these models, to ensure they're accurate, scientists will need to carefully compare them to real embryos. Second, they're already improving our understanding of early human development, and they could in future improve human health, from fertility issues to developmental disorders. And third, and this is crucial, this is about fundamental research, not about reproduction. We'll hear later about technologies that could potentially, somewhere down the line, be used in reproduction, but that's not the intention with these embryo models. However, If it's to remain the intent, then the law should make sure that it can't be used in other ways, that it can't be used for reproduction. And finally, for this progress to benefit everyone, our laws and regulations need to keep pace. They need to ensure that the boundaries are in place to maintain the public's trust. By embracing the science within strong legal and ethical framework, we can turn new knowledge into new clinical advances. So thank you very much for your time and attention, and I look forward to questions and to discussion. And I'd like to hand over now to my esteemed colleague, Professor Emily Jackson.
Thank you, and thank you to Lancaster University for inviting me, and thank you also for something else on a rainy evening. I want to talk about a new technique that's related to what Emma's been talking about, which is generating a great deal of excitement. There are lots of US biotech startups which are investing heavily in this, but there's also quite a lot of excitement from some more cautious scientists working in universities in the UK. And that's the possibility of taking stem cells, very much like what Emma was just describing, so possibly a skin cell, reprogramming it into this pluripotent state where it can become other tissues and cells in the body, and using those in order to make sperm and eggs. So these are described as in vitro derived sperm and eggs, in vitro derived gametes, which was a collective term for sperm and eggs. These in mice have been used to create live offspring. So this is taking a skin cell, making a stem cell that's pluripotent, making a sperm or an egg from it, and then using that to do in vitro fertilization and implanting it into a uterus. So some success in mice, but not in live offspring. But there's a consensus that it isn't currently safe enough to use in humans. There have been too many early deaths, too many abnormalities in those mice. So there have been live offspring, but not sufficient to establish safety. So it's not currently safe enough to do in humans. And currently in the UK, it would be illegal, actually, to use human stem cell-derived sperm and eggs in treatment. But that could change. I want to tell you a little bit about how and why that might happen. So I'll come on to use in treatment in a second. But what's collectively described as in vitro gametogenesis, making sperm and eggs from stem cells, could also be useful for research purposes in the same way as what Emma's talked about with embryo models. So if you could make sperm and eggs very easily in large numbers in a laboratory, you can use them to create embryos that, again, you can do research on in order to understand more about things like the multiple causes of IVF failure, because human reproduction is actually pretty inefficient. So in a typical IVF cycle, roughly half of the embryos that are transferred might implant, but fewer than half of those will actually lead to an ongoing pregnancy. So as Emma said, average success rates from IVF are about 30%. That's an enormous amount of partake in every cycle. So these could be useful, very, very useful for helping to understand more about what's going on in the early embryo. But that's not where most people are getting very excited about IVG. It's the future clinical use of stem cells-derived gametes that people are getting particularly excited about. And there are lots of reasons for that, and I want to explore some of those and some of the implications of this. So obviously the first, most obvious use for stem cell-derived sperm and eggs would be to replace the use of donated sperm and eggs. So for people who can't use their own gametes, their own sperm and eggs in treatment, and have to maybe rely on donor eggs and donor sperm, if they could just make sperm and eggs themselves from stem cells, they wouldn't need to use donated sperm or eggs. And there's been quite an increase in recent years of the number of people using donated sperm and eggs. And of course, if you could make your own from a skin cell, then that sperm, that egg, is genetically identical to you. So using them in treatment means that you avoid all of the issues that there are in relation to to donor conception around things like anonymity, telling children about it, and maybe children finding out about half-siblings and other relatives by using ancestry.com and revealing all sorts of facts that they didn't know about themselves. All of those disappear if you could just make eggs and sperm out of your skin cell. Another really major implication is that it changes how we feel about eggs in a very dramatic way. So eggs would no longer be in scarce and diminishing supply. The images here are from a public engagement project I did some years ago, and they're a visual representation of women in declining ovarian reserve, which, as I'm sure many of you know, female babies are born with all of the eggs that they'll ever have, and they lose them over the course of their lifetime. And of course, that fact about eggs is incredibly significant for human reproduction. It's why we talk about the biological clock. And it's why quite a lot of people need to resort to things like IVF in order to start a family. But can you see how, if you could just make eggs whenever you like, whenever you want to, that no longer needs to be the case. Eggs are no longer this very scarce, precious thing. And instead, they become more like sperm, easy to make, plentiful. And that changes, in a way, how we think about reproduction in all sorts of ways. It means that you could make very large quantities of eggs, which might mean that you would have very large quantities of surplus eggs in storage. You might have to make decisions about what happens to them. You could also make very large quantities of embryos, and again, that might lead to very large quantities of surplus embryos in storage. One possibility, which isn't very likely in practice, but it would be an entirely new thing, is the risk of women having children to whom they're genetically related, but without knowing about their existence. And we know that happens for men. They can have a sexual encounter and not know that it's led to a pregnancy. But whether a woman conceives through IVF or naturally, she's going to know about it because the processes involved in IVF are pretty intense. And obviously, if a woman conceives naturally, she'll know and has a baby that way. Of course, she'll know about it. But if you could just take a skin cell, make an egg and make a baby, there's a possibility that a woman could reproduce without having known that that's happened. I think it's widely agreed that when this becomes safe enough, and estimates vary on this, so I think the US startups are saying soonish that they're close to clinical trials. Scientists in the UK are saying more like 10 to 20 years, but that's not that far away. When this becomes possible, I think the demand is likely to be pretty significant. So around a fifth of cycles in fertility treatments involve donated sperm and eggs. But of course that demand doesn't include people who use maybe informal sperm donation, getting sperm from a friend or from an online sperm provider, and there are increasing numbers of those. And I think we could anticipate that most people would prefer to use this, if they could, to using somebody else's sperm or eggs, because, as I mentioned, this would be, in a sense, genetically your child. One thing that appears to be possible in mice, which is a whole other dramatic implication, is that you could make eggs from male stem cells. It's harder to make sperm from female stem cells, but not necessarily impossible. And of course, that gives rise to the extraordinary possibility that a same-sex couple could have a baby that was genetically related to both of them. And I think demand for that is certainly likely to be significant. I've mentioned there's a race mainly in California to get there, to get to the point of being offering this in treatment. These companies, some of them are very, very heavily funded by the Silicon Valley AI tech bros, as you might call them. So Sam Altman is a massive funder of conception, with the aim, I think, he hopes of being able to maybe use this himself in the future. So if they announce that they're enabling people to do this in California, I think we could predict that you're going to have lots of very well-off people travelling. But of course, what we know in relation to other sorts of reproductive care, but also other sorts of treatments, is that people who maybe can't afford to go to California might be looking for lower cost destinations. We know that happens with surrogacy, for example. So I think in the early stages, if this is offered overseas first, we're likely to have a real need in this country to tell people about maybe safety concerns, questions they need to ask. People are going to need access to clear evidence-based advice. And of course, when you do something that's new, it's very important that there is some kind of overseeing of children's health to make sure that the children are doing okay. So there are obvious safety concerns when you have babies in a completely new way, and there's a need to keep an eye on that. It can also have an impact on other sorts of fertility treatment. So one obvious possibility is it actually becomes routine in every IVF cycle, because the tough bit of IVF for women, or one of the many tough bits of IVF for women, is ovarian stimulation and egg retrieval, which involves injecting yourself, multiple scans, and then actually having to have eggs surgically removed. You wouldn't need to do that if this became possible. Why go through all of that if you could just take a skin cell and make an egg that way? So it could actually eliminate half of an IVF cycle. It would certainly probably eliminate egg freezing, because why on earth would anybody freeze their eggs if you could just make them on demand whenever you needed them? And I think that gives rise to the interesting possibility that egg freezing, which we know many young women are currently doing, becomes this kind of time-limited practice. It really only became available widely in 2015, but if it becomes not needed in 10 years, there'll be this funny 20-year period where women were doing something kind of new, radically new, and navigating choices which are then superseded by technology and no longer needed. I think it could probably eliminate donor conception, and I think some people might even say, is it ethical to use an egg donor, to put an egg donor through the processes of stimulation and retrieval if you don't actually need to? It could also have an impact on selection, on pre-implantation testing of embryos, because at the moment you can do this, but if a couple in a cycle, they might create 4 embryos, 6 embryos, you can test those embryos, but you haven't got very much choice. If you could make 100 embryos very easily, you've got much greater possibility of using selection. And obviously that makes lots of people very uncomfortable, but it also leads to, I think, quite an interesting question about, does our discomfort with people selecting desirable traits, is that very different from, in a sense, the whole purpose of this, which is to enable a desirable trait, i.e. being genetically related? And we tend to think that that's natural, that that's not perceived to be, selecting for that isn't perceived to be problematic in the same way. There's been some public engagement work on IVG, but not very much. But it's very interesting that the public tends to be, when they hear about it, quite excited about the possibilities here and quite accepting of almost all of them. So people are in favour of almost all of these things here. So getting rid of the really tough bit of stimulation and retrieval in IVF, that's, people are happy and excited about that. Gamete donation, likewise. Egg freezing, likewise. There's even quite a lot of support for same-sex genetic parenthood. But where the public tends to be much less excited, I would say actually quite negative in the engagement stage, is postmenopausal motherhood. That seems to be a line where people are not comfortable because, of course, you get rid of the biological clock with this technology. But that seems to be the thing, the area where the public seems to have more concern. So I just want to close, I'm not sure whether you'll all be able to read it, but with a quote from Deborah Sparrow, who's a US economist who's written quite widely on these issues. And I think it's helpful to remind ourselves that when IVF first happened back in 1978, it was seen as really destabilising and really quite alarming, and now it's a fact of life. As Emma said, there's on average 1 baby in every classroom in the UK is conceived by IVF. Is the same going to happen here? Are attitudes going to change in relation to this? Well, things can go from being scary and destabilising to the nice couple next door. So we know attitudes can change. Will they with this? That remains to be seen. So I'm going to stop there and hand over to Steve.
Okay, well, thanks everyone for being here, and thank you to excellent talks from Emma and Emily. I'm Stephen Wilkinson from Lancaster University. And I'm going to talk today about a slightly broader topic, which one would sort of affects all reproductive technologies, which is the question of how they could be paid for, particularly whether they should be paid for through public funds, which in this country generally speaking means the NHS. And I'm going to ask a number of questions about which technologies should be funded, under what circumstances should they be funded, for which people, and in particular, and the fourth box there really interested in the most, how should we decide on what kinds of discourse and considerations apply here? So I should add that, my discipline, unlike our other two speakers, my disciplinary background is philosophy, so we take a slightly different approach, and it's particularly interested in sort of teasing out what kind of moral arguments work and why, and just looking at that's our bit of service, so I'll use financial instead. I'll start off with a few examples. Actually, I'll start off by giving you a quick outline of what we're going to do. So we've got some examples, and then I'll talk about what I call the basic requirements for state funding, which are effectiveness, cost effectiveness, and safety. And then the three potential objections that people might level at funding new reproductive technologies. So I'll come back to those to say at the end. So, but first of all, three examples, just to give you a kind of idea of the sort of thing I've got in mind. So one of them is uterus transplant. So first British successful uterus transplant, by which I mean none which resulted in a live birth, was actually quite recently, less than a year ago, so February 2025. According to the team, cost between 25 and 30,000 pounds, although the Swedish estimates have suggested that the full process of going through uterus transplant IVF with that follow-up is around €100,000, so it's quite an expensive thing. Existing UK cases are charitably funded, so they could, and it's already been starting to be discussed, they could be to learn for NHS funding of uterus transplants if they become more mainstream. So uterus transplant is a way of treating women with absolute uterine fertility, attachment fertility, because they have a uterus at all, either because you're not born with one, or because it's actually moving forwards become damaged in some other process, for example, other medical treatments. So that's something that is already benefiting people, and there could be a question about whether we should become it or not. The second example, which I will say most nothing about because we've just had an excellent talk for it already, is IVG, or in vitro gametogenesis. But again, if this becomes something that could be used in reproduction, again, the question will arise about should it be funded, which use of it should be funded. And my third example, which again is perhaps pushing, perhaps more futuristic and speculative, although it is happening in the research setting, or is about happening in the research setting, is artificial womb technologies or partial exogenesis. So it's not happening as far as I'm aware in this country, but certainly American, Japanese, Australian teams are working on coming up with something which is, there's a lot of debate about what you should call this. I've called it artificial womb technology because I thought it might be to give you the general idea of what it is. It could be called ectogestation. Some people call it artificial placentas as well, but essentially the idea is that you create a kind of fluid-based environment where neonatal fetuses, again, is how original it is actually, are principal sort of survives keep going. This has been had some success in animal experimentation, is set to move into human experimentation in the future, and not in this country as far as I'm aware. So that's the sort of thing that we might have to think about. I don't know exactly when. The uterus transplant is now, or very soon. The other one's a bit more speculative, but the people who are sort of advocates of these technologies think that this should be something we'll have to deal with in 5, 10, 20 years. So it's not sort of super high, I'm assuming. So the basic requirements, I thought I'd put these on the table just so we think about state funding, NHS funding. Seems to me that there's 4 basic requirements that anything's going to have to meet in order to be a successful candidate for public funding. It needs to be sufficiently effective and safe. We need to know it works, so does it harm people, or does it harm them more than an acceptable level of risk? It needs to be sufficiently cost effective, meaning that it delivers as much good per pound as other comparable things that you fund. It needs to be within the scope of the health service, so it's not just enough cost effective. There has to be, a health thing. We're going to say that in a very general sense. So not housing, transport, defence, so it's very good that our bins are collected. It's not that for a health thing. So these are all cost-effective public interventions. So not everything is a health service intervention. Our finding shouldn't be sort of intrinsically ethical for some other reason. So, and obviously, with reproductive technologies, people do have lots of objections to them which are in their way to do with many importance. I'm going to focus today, for reasons of time, almost wholly on three, which is what things are blocking within the scope of the health service. There's a sort of longer version of this talk which goes into defining cost effectiveness, but probably shouldn't go do that. I'm going to miss that one. So back to the outlines. I'm going to look at these three objections, which, and just to be clear, these are not necessarily my objections or things that I believe, but they are things that kind of come up and that people do say as objections to publicly funding reproductive technologies. And I say reproductive technologies because many of these will apply to new technologies in the sense to old ones as well, like IVF. Some will be about it, the features of reproduction rather than the newness of it. But new ones are obviously especially sort of controversial. So the first thing that people make is it's going to be overpopulation or the environment. And they say that essentially some version of there are too many people on the planet. And this could be for a variety of different reasons. So climate change is a sort of current it, but it could be food or water shortages or any shortages somewhere. And so if there are already too many people, they say, why are you spending sort of public resources on making building? So that is basically what argument. Okay, it sounds plausible in some ways, but there's a number of reasons why I think we probably should be too convinced by this argument. I mean, the first one is empirically, are there too many people? I mean, I think my answer is I don't know. I'm not sure how you would decide what the right amount is, but it's worth putting as a counter the fact that many countries have got quite low birth rates, and I think up to this culture concerned about aging population, including the workforce declining and so on. So that's one thing I think about. You could argue that certain things like climate change can be dealt with further ways. So if you completely decarbonise your energy sources, for example, then you become use them as the actual people. And so it's argued that even if there are too many people, this is a dangerous area to stay involved in and try to encourage pushing against the coercive diet maybe people have. So there's a few worries about that argument. Second set of worries is about whether it's fair to place. So let's take a different tack. As philosophers, you like to make an assumption and then see where it holds first. And let's take a different assumption. Let's assume that there are too many people and there is a legitimate capitalist goal to reduce the number of babies of the world. Right? Now, even if that were the case, I think there's definitely a question about whether doing this by not funding reproductive technologies is the best policy option. And I think you could critique on two guys. First of all, is it the most effective? And secondly, is it fair? So in terms of effectiveness, as I said, it wouldn't be that effective because the sort of things which we've been talking about, say, like IVG and the Wilkinson fault and so on, the numbers involved there are likely to see the future to be very small. So if you really need to make an impact on birth rate, not funding these things we've got to make that much difference. So even now, only 3.1% of births in the UK are IVF. IVF, and the majority of those probably private. Why did we send them anyway? Not even in the NHS. So even if we stop IVF, that was the obtuse set. But if you're talking about IVG and root process, that'll be tiny numbers, so it won't really become possible. The second kind of argument, which is probably speaks to me more in a way, is about fairness, because I think you could ask whether it's actually fair to expect people with infertility to shoulder the sort of whole burden of trying to get population down by not having services provided through food. I'm going to try an analogy. You like talking to them, this analogy, and again, it's in bioethics. So one analogy would be this. And imagine that your stated goal is to make sort of less traffic, less cars, less parking in the city centre. And during a discussion about disabled parking spaces, your interlocutor said, I think we should completely defund disabled parking spaces because there are too many cars in the city centre, and our policy is to reduce traffic or reduce car parks, and let's get rid of all the disabled parking spaces. Seems to me that's not a very good way of going about it. You're sort of, if you're like, picking on people who have got a particular need. They need to meet they've got a mobility need, which means that they need these parking spaces, rather than having a much broader based policy way to actually just discourage everyone from driving into the city, or you need to have road charging or car park charging. So this is supposed to be in some ways analogous to what's going on in the case of defunding reproductive treatment in order to keep the population down. You're sort of picking on these groups that are already struggling with infertility, and you're saying you're not going to fund your services But really, a much fairer way of doing it would be have a much more broadly distributed cognitive ways of just intensifying to encourage you to have your children some of our non-fair areas of right. Anyway, see what we later about. Second kind of argument tends to hinge on whether infertility is a disease. And some people claim that it isn't, or that it's a kind of disease which isn't like others. And that it means it doesn't bear at the same level of public support. So let's push back on this is that, I mean, most official kind of clinical bodies and guidelines do recognize infertility as a disease. So I won't read it out. There's just one definition there of what it is to be biologically infertile. So it is recognized by most clinical bodies. However, there is a difference. I mean, I would be to say there is a difference between infertility and some other conditions. So a paper written by my colleague Nick Levine, so I think is on the back there, and I put it like this. And again, we're just to be clear, we're sort of, that's under our position, we're just outlining the argument. So for individuals who don't want children, infertility is a worst unusual characteristic and may even prove slightly advantageous, eliminating the need to worry about accident or pregnancy. Indeed, before the advent of effective contraception and safe abortion services, infertility would have been highly advantageous to any woman who didn't want children, and still is in many parts of the world. Thus, it may be argued that infertility is not a disease because its ability to cause harm depends on people's preferences. So, as we put it there, infertility, as I put it in a slightly more basic ways, it's not bad for you unless you want to have children. And of course, the more you want to have children, the more children you want, the worse it's for you. So it's dependent on your preferences and desires in a way which not all conditions are. I mean, if I have a pain in my leg, that's a bad thing, but it's not sort of dependent on my desires to the same extent. Might be a bit if I want to go gunning or not. So that's I think intrinsically bad in a way than the things. However, against it, I think we should say, first of all, that there's probably a number of other conditions which are like infertility in this respect. So we can think about colour blindness, losing your sense of smell, erectile dysfunction, some ability limits. I mean, all of those conditions could be better or worse depending on what your preferences are. If you want to be an electrician or a fighter pilot, then colourblind is much worse, and if you don't, then it's less bad. Sense of smell is much worse if you are the wine taster or a tea purchaser or something like that. They can each of those things is going to be better or worse depending on what the preferences are. So infertility sort of not on its own is still in that respect. Also, it's worth bearing in mind that unwanted infertility frequently does cause substantial psychological distress with impacts on mental health, and so there's a sort of secondary way in which infertility can be a disease or a disorder. But moving on to the final argument. So the final argument which I wanted to mention is about alternatives. And in some contexts there are more alternatives on the table, but I'll just stick now with the idea of adoption, because people who object to publicly funding fertility services do sometimes say that why are these people looking into other options by going down the adoption route and so on. And I think there are kind of, a number of different reasons why that's not a strong argument against public funding. I mean, one of them is why it probably also makes sense for you to consider adoption as an option. But of course, the experience of adoption and having one's own biological child are quite different. I mean, not everybody's circumstances are right for adopting a child. And more importantly, again, it's a little bit like the first argument. I think the point about social responsibility to adopt children is one that if that social responsibility exists, it would apply to all people, not just people themselves. So anyone who's considering a child should, on this view, seems to me, think about adoption. But it doesn't mean that doesn't mean we should be singling out things infertility particularly to have to do that. So conclusions. So to be clear, I'm not arguing that all reproductive technologies should be funded. I'm just trying to push back a little bit on some of the in-principle objections that people come up with. So new technologies like the ones we discussed may be extensive and will come with course of the funding. They need to meet all the same principles of efficacy, safety and cost effectiveness that any other field would do, and that might be quite difficult for them to do in the early stages. But what I'm arguing here is that in principle, there's no reason why we shouldn't consider these stages to be candidates for public funding. And the arguments that I discussed here, although they are, I think, interesting and important, and possibly apply in some selected areas, are not sufficient for us to actually rule out public funded as the reproductive technologies across the board. So I'll stop there. Thank you very much. And so we're going to spend a little bit of time. I'm going to ask Emma and Emily some questions, and we're going to talk amongst ourselves for a little while, and then we'll invite you to, as the audience, to pose some questions. First of all, thanks again for your excellent presentations. So you mentioned Emma, you mentioned the 14-day rule in your presentation. I wonder if you could say a little bit more about what it is, but also whether you think the 14-day rule might change, and if so, what sort of impact that will have on stem cell-based embryo models.
Okay, so the legislation that governs embryo research is called the Human Fertilisation Embryology Act, and that was set out in the 1990s. And that flows from a report called the Warnock Report, which looked into various aspects of fertility treatments, including IVF, but also looked at this issue of embryo research. The problem being that if you research on an embryo, you then will have to destroy that embryo. And a section of the population would find that morally very troubling. Another section at the opposite end might find no problem with that at all. So the Warnock Report tried to find a solution to that, given that there was never going to be a consensus. And the solution that Dame Mary Warnock and her committee came up with was a consensus. And the consensus was that we might allow embryo research, but with a very strict limit on it. So that beyond 14 days, or the primitive streak, the appearance of the primitive streak, which is where the body formation, or the formation of the embryo, goes from 2 layers to 3 layers, and the body plan starts to form, then that research should be prevented. And that would be a hard line, so no research could ever go beyond that point. So that has worked very well as a compromise since 1990. But we're getting to the stage now where it would be possible, it would be feasible for research to go beyond that point. And as I spoke about in my presentation, there could be many advantages of doing so from a scientific point of view, because it's that period from 14 days to around 21 days where gastrulation happens, and so many of the issues that lead to miscarriage or to problems or to congenital issues. That's when many of them arise, and we don't know enough about that period. So there is an argument from a scientific point of view that maybe we should extend beyond those 14 days for those scientific purposes. But on the other hand, we have this consensus, this agreement, based on the fact that the embryo is special to us in our society, and the risk is that if we go beyond those 14 days to another date, that could disrupt that consensus and could potentially cause mistrust by the public of science. So a debate is being had about the trade-offs and about whether or not that might be something that would be acceptable. In some countries, there is talk about pushing the 14-day rule to 28 days, because after 28 days, it's easier to do research during pregnancy. It's easier to see what's happening. But up until that 28-day period, we could learn an awful lot about early human development if that research was sanctioned. So a number of different countries are thinking about that possibility. And in this country too, that is being debated, and the fertility regulator, the HFEN, has set out a position if they would be amenable to looking at that as a possibility if the government was willing to change the law. So that's the situation that we're in. The Nuffield Council on Bioethics, which is the, as I said, essentially our ethics committee, our national ethics committee, is running a project on that at the moment, looking at the scientific issues, the ethical issues, but it's also going to run in the near future a public dialogue which starts to talk to the public, not just simply getting the views of the public. Dialogue means a two-way conversation. Also talking to the public about the potential benefits, about why we have the 14-day rule in the first place, in order to try and gauge the public perceptions of extending the shawl a little further. So that's sort of where we are at the moment with things.
Yes. Thank you very much. Did you have anything more to add on this? No. What do you thanks for just thanks so much. So I'll flip over to ask Emily a question. So you mentioned you talked about how IVG could hugely increase the supply of eggs and embryos. And I just wonder, actually, both of you really, do you think it would change public attitudes or the way in which we value embryos if this thing happens, so they're much more readily available? So the embryos and high eggs and any scarce in it. Do you think it would lead to a sort of profound cultural change in the way people think about the embryos, or just?
I mean, it might do. I think we don't know yet what its impact would be, and I think we're so the facts about reproduction are so deeply ingrained in us, and they changed really dramatically last century with the possibility of fertilisation outside of a woman's body. So that was unprecedented and seen as just the most extraordinary thing. It's never been possible before. So there was a huge, in a sense, huge shift in the middle of 1978 when Louise Brown was born, and that I think altered how people thought about reproduction. But the impact of scale, I think we just don't know. I mean, because I think at the moment, because eggs are so precious, as a result of that, embryos are scarce and precious because you need eggs to make embryos, and there aren't many eggs. That means there aren't many embryos. How will people feel if that natural break on scale goes? The idea that you can manufacture these things, you can manufacture the embryo models that Emma talked about in large numbers. I think it changes things very dramatically, but how people are going to feel about that, I think we just don't know the answer. And that's why, going to what Emma just said, that's why public dialogue, public engagement is so important in order to properly understand what matters to people and how they feel about them, because I think at the moment we just don't know.
So we'll see it.
Absolutely.
Can you say something?
Not an awful lot. I think that's absolutely right. It's something we need to explore and work our way through. I mean, one of the things we were talking about in your talk was the potential to end up with an awful lot of embryos and gametes in storage, and that's already becoming an issue, that we have a lot of gametes and embryos in storage, and that raises questions about, well, what do we do once they're in storage? And how long do we keep them in storage? And there's a massive cost to it as well. I mean, a huge cost to it. Who would foot that bill? So there might be some economic drivers that also make us think and reassess, well, what do these particular types or methods mean to us as we go forward? We might end up with a situation where we start to think differently about different ways in which the human reproduction comes about. We just don't know, and I think these are things that we need to explore.
I think on the point about massive numbers of embryos and eggs in storage, one interesting finding of social science research with people who have embryos or gametes and eggs in storage is that people often find it very difficult to make decisions about them. I mean, I know somebody who's a professor of reproductive medicine who throws away the letters from the fertility clinic. So somebody who knows all about exactly what the issues are, but just doesn't want to think about it. Because it's very, very hard to think about, particularly if you've had maybe children through reproductive technologies. The idea that you have material in storage that could be siblings, the idea of destroying those is very difficult for people. But of course, for clinics, if they just have to store ever-increasing numbers, this becomes practically very difficult. So I think it will be really interesting in the coming years to see how the numbers issue changes people's views.
So a question for both of you, and possibly for me too, is at the end of your presentation, you have this quote from you, Deborah Spark, which essentially was saying that my IVF seemed to be pretty shocking when it first came out. Usually a 2S trial outside the body. And so perhaps IVG or perhaps stem cell-based embryologics or whatever other new reproductive technology might seem a bit far-fetched now, a bit shocking, but we tend to get used to these things and domesticated in a way. Do you think is that true of all of the developments that you're currently aware of, or are there any sort of outliers where you think it's sort of so unusual and so departs so much from established social convention and behaviour that it would not be accepted?
So one, I think, where you could point that I think there's quite consistent public hostility to us is cloning. I think the idea of people cloning themselves makes people feel very uncomfortable, which is interesting in a way because identical twins are clones, and yet we don't feel uncomfortable about identical twins. But I think obviously that's a natural phenomenon. The idea of somebody deliberately creating somebody who is genetically identical to their next, people feel very uncomfortable. And I'm not aware of that having been done in humans. Maybe if it was done, people would get used to it. But at the moment, that seems to be something people are still against. But I think we can't really tell whether something will become domesticated in just one of those things until many years in the future. I think at the moment, we just honestly don't know which way this will go.
Mm.
I think it's interesting, sort of sociologically, that wherever you are in time, you think, wow, we're on the cusp of the most amazing breakthrough ever. And it's natural that we feel like that, partly because we don't know where something's heading. We can't really tell precisely what's going to come of it. But also it might not be fully regulated yet, and so it concerns us, we worry about it. IVF was so enormous, it was such a massive, massive change. But there may be ways in which we're about to have similar sorts of change, and then we'll have to sort of work out precisely what we need to do about those things, which is exactly what I'm talking about, of course. But for me, the things that really strike me about these new changes, one of them is the scalability, the fact that there could be such huge numbers of it. That's something that we've never dealt with before, nearly with IVF, that it was so novel and exciting. And another is as you both talked about, the impacts that it could have on families. I think that's on the way that the family is conceived, and the changes there, I think could be really unprecedented. And then one other thing is the way that they can sometimes come together, these different technologies, which is quite hard to predict in advance. Already over the last couple of years, there have been ways in which we thought we were dealing with separate technologies, and then the technologies started to come together in certain ways. So there's another way you can use stem cells, and that's to create organoids, which is a stem cell-based parts of an organ. And if you put those organs together with, let's say, a stem cell-based embryo model, and you put that together with a uterine model, then you can get the interactions between those systems, which is, again, hugely exciting. Similarly, IVG or stem cell-based embryo models alongside artificial womb technology. If you put those together, again, the possibilities are quite extraordinary. So yes, I think there are ways in which this does seem really quite incredible and quite unprecedented.
Yeah, I understand. And I suppose we don't know. Although many of the current the intended current science that we're aware of anyway tends to be quite benign and in one way conservative in the sense of it sort of giving reproduction back to people who have been because they're suffering from biological infertility. So it's sort of quite. In a way, it's curative and that's sort of straightforward. But of course, there are some emotions that, bioethicists tend to get quite excited about the discussion of these things which we could talk about. So in the case of IVG, obviously there's the theoretical possibility of having more than two genetic parents or multiple genetic contributors to the person, or even there's been discussion of one person being the originator of a child and both gametes come from the same person. Though, as we discussed earlier, that's quite significant safety issues around that, so probably that's unlikely to happen. And in the case of artificial intelligence, what's happening now is very much always therapeutic, but obviously science fiction and bioethics is full of tales about whole sort of full exogenesis for a child is brought to birth, wholly outside body. So those sort of things are quite different, I think, from what we're experiencing now.
I think they are. I think they go to the heart of, I think, a question which we're very lucky about in the UK, which is we have quite effective systems of regulation here. And so when you do talk to the public about how they feel about these sorts of technologies, one of the key things that comes up goes to what Steve was talking about. People are worried about inequalities. And is this only going to be available to very rich people? Is it going to help me and my family? So that's something that worries people. But another is rogue scientists. And the idea that you might say that it's, for example, the embryo models that everyone was talking about aren't for reproductive use, but how do we know that somebody isn't doing that? And so I think regulation is incredibly important for giving the public confidence that this research can proceed, but without people doing things that are unacceptable and unsafe.
But fantastic questions, thank you so much. But in particular, can we please thank Emma, Emily and Steve for their presentations, their panel discussion and in answering the questions in the traditional way, please.